Good morning, students. So, in the previous lecture on Friday, we discussed the wireless LAN and see how these networks should be connected by using the wireless LANs. So, even if you are connecting the system or mobile system using your hotspot, that means you will be implementing the wireless LAN. So now we will see the next topic is the connecting devices using the LANs. So in this section, we divide connecting devices into 5 different categories based on the layer in which they operate in the network. So for the application layer, there is a gateway, and for transport layer, the routers or a 3-layer switch. For network layer, there is a bridge or 2 layers. On data link layer, we have repeater or hub, and for physical, we have passive hub. So basically, we have two main things in this, that hub and switch. So hub is used for the basically difference between hub and switches. Hub is used for broadcasting the data, whereas switch is used for unicasting and multicasting the data. So, do all of you know about the broadcast, multicast, and unicast things? Yes, everyone. Do you know about the broadcast, multicast, and unicast of the data? Okay. So, this is the division of this connecting the devices. So, first is the repeater. So repeater connecting two segments of a LAN. So here we are using the repeater. So at this point, the repeater is being used in the yellow color. That repeater is used to repeat or to re-strengthen the signals. Now, suppose as soon as we increase the distance of the connecting devices, the data may become lost due to the distance traveled by it. So, what repeaters will do is they will regenerate the signals over here as soon as the signal is received by the repeater. They will regenerate the signals and convert it into its original form and then send to the segment 2. Now, suppose the data is coming from the segment 1 and suppose the distance is much larger than the normal distance. So, the data will be going to this repeater. At this repeater, the processing is done that it will be converted to its original form, whatever the data is being lost, and then the correct data will be transferred to this segment 2. So that is why this repeater is used to regenerate the signals. So what the repeater does is a repeater connects the segments of a LAN. A repeater forwards every frame. It has no filtering capability. And that I have told you that a repeater is a regenerator, not an amplifier. Basically, it will regenerate the signals. Just for example, like it will, suppose we have a data 110011 and it is traveling to the longer distance, and suppose for this we data received by the repeater is 1100. Now this one has been lost. So at the repeater, techniques will work and it will regenerate the signal to 1101 and send it to the other system. So it is a bit for bit copy, removes noise, but do not correct or detect the errors and recover the signal strength. So it is not able to correct the or detect the error. This is just the example that I have taken. Basically, the repeater does not correct or detect the errors. Basically, it will regenerate the signal strength so that the data on that signal should be traveled more than the normal distance. Clear? So the function of a repeater is regenerating the signals. Now see, the corrupted signal is being there. That means data are being lost at this repeater. It will regenerating the signals into the original form. Similarly, basically that is from sender to the receiver, and this is receiver to the sender, because in both the cases signals may lost due to the longer distance traveled by the signal, and again the data is being corrupted over here, or the signal is being corrupted. When it comes to a repeater, it will regenerate the signals. So this is the task of this repeater. Clear? So next is the hierarchy of hubs. So basically, this hub is actually a multi-port repeater. The data will be traveled from one system to the multiple ports, and as well as it is used for broadcasting data. Simply broadcasting means that multiple receivers will receive these signals. So suppose this is the hub. This is the hub, and the hub is connected to another hub, and this is the second hub that is connected to the parent hub, and with that hub, the multiple systems are connected. Okay. So when the data, first of all, the data will be traveled from the number of ports connected to the hub, and multiple hubs will be towards the multiple hubs. This data will be traveled, and from this hub or these hubs, data will be traveled to the systems. Clear? ठीक है बेटा, समझ आया? तो हब मल्टी पोर्ट रिपीटर है, मल्टीपल पोर्ट से ये कनेक्टेड होता है, एंड इट विल ट्रांसफर द डेटा टू द मल्टीपल सिस्टम्स फॉर ऑल द सिस्टम्स. You can also say that. So then the bridge between the hubs can check the MAC addresses. Now suppose what will happen is this is the system, these are the systems, and they are connected suppose with each other with this hub, and similarly like this they are connected, sorry, they are connected with each other, and we have the systems like 1, 2, 3, 4. Now every packet or every data has the MAC addresses. Okay, so this is the machine address of every machine or every computer, and it is the unique address, and it does not change by changing the internet company, because your IP may change as per your service provider, but the MAC address will not change. It is just like, to easily understand it, it is just like the IMEI number of your phone. You may change the Idea SIM, Vodafone SIM, or Airtel or Jio SIM in your phone, but your IMEI number should not change. Now, suppose this hub has transferred the signals, transferred data to all the systems, but that data is required for hub 4. So basically, bridge will check is that it has sent the data to 1, 2, 3, and 4, and at this point, some filtering decisions are used whether to get the data, whether to forward the data, or whether to drop the data. So if now suppose the data is for 4 only, and 1, 3, and 2 will drop the data, whereas 4 will have the data. So table shows the map between MAC address and ports in Ethernet. Ethernet switch is a bridge device. So let's see the video. So this is the bridge device, and it will see that what data will goes to the which system, and similarly as per the MAC addresses, it will accept the data or it will reject the data. Similarly, it can be implemented over here. Clear? So you can see that we are just sending the email, and see that how many processes are being done at the backend. So these are the routers, 3-layer switch connecting independent LANs and WANs. So these are the 3-layer switches. So next is the virtual LAN. We can roughly define a virtual local area network as a local area network configured by the software, not by the physical wiring. So like we have various softwares that are used for virtual local area network. Basically, before implementing the physical LAN. Okay, so virtual LAN is not by the physical wiring. Basically, Wireshark software is used to create the virtual local area network. So first of all, that LAN will be implemented over the Wireshark, and then many tools are there, like network simulator is there, MATLAB is there, Wireshark is there, that are used to create the virtual local area networks. And then at that point, the network is configured rather than go directly on by the physical wiring. So a switch connecting 3 LANs like this, the switch is used to connect the 3 LANs. Physical wiring makes it hard to dynamically change group allocation. So that is why we are using it on the softwares. and here the VLAN software used like virtual LAN 1, 2, and 3. So similarly, like two switches in a backbone using VLAN software. So these two switches are used, and again this is done with the help of net software. Okay,